Hello friends, this is Praveen. Welcome to our YouTube channel. In today's lecture I will discuss about position vector, displacement vector and the numericals based on these terms. So let's start with the position vector. So what is a position vector? A vector which gives the position of a particle at a point with respect to the origin of a coordinate system or reference point is called position vector. In our daily life, very often I used to tell my position to someone else. For that I used to take famous buildings, famous places, famous shops, bus stops or railway stations as my reference point, with respect to which I used to specify my location in terms of distance and direction. But here, for the convenience of geometrical representation, the origin of Cartesian coordinate system is taken as the reference point. Here I have taken the two-dimensional rectangular coordinate system whose origin O is taken as the reference point. Suppose there is a point P in this xy plane whose position vector is need to specify or we have to find. For that, let us consider its position coordinates be x, y. Now if I join point O with point P, and if I give a arrowhead at this point, then this will be converted into the form of vector. Suppose this is given by r vector. So here OP vector equals to r vector is called position vector of point P with respect to point O. With respect to point O. Now if I drop the perpendicular from point P on x-axis and on y-axis, then this value is called as x and this value is called as y. So in order to express this x into the form of x coordinate and y in y coordinate, I need to multiply this x and y by the unit vectors along x-axis and y-axis. Therefore I can write here xi cap equals to x vector, which is position vector along x-axis, or it can also be called as rectangular coordinate of r vector along x-axis, and if I multiply by y with j cap, then I get what? Y vector, and this is y component of r vector. If x and y both are components of r vector along x-axis and y-axis, then we can write r vector equals to x vector plus y vector, and therefore it is equal to xi cap plus yj cap. This is what? This is position vector of point O with respect to, this is position vector of point P with respect to point O in terms of its rectangular components along x-axis and y-axis. So if I want to calculate its magnitude, then its magnitude is given by r equals to square root of x square plus y square, and suppose this position vector is making theta angle with respect to x-axis or from the x-axis, then its direction can also be given by tan theta equals to y by x. So this is the magnitude and this is the direction of the position vector of a point P or the position vector of a particle at point P. Now if this point P is to be represented in three-dimensional coordinate system, then I can write in three-dimensional coordinate system I can write r vector equals to xi cap plus yj cap plus zk cap, and its magnitude is given by r equals to square root of x square plus y square plus z square. In order to find its direction cosines, we have to find out cos alpha, cos beta and cos gamma, which are equal to x upon r, y upon r and z upon r. So from this formula I can find out the direction cosines of r vector from x axis, y axis and z axis. Now if I can know the position vector of the two vectors, then I can easily find out what is displacement vector between the two positions of a particle. So let's discuss about the position vector of a particle. Okay, now let's discuss about the displacement vector in 3 dimensions. Here I have considered a 3-dimensional rectangular coordinate system with point O as the origin. Here I have considered a particle at point P with coordinates x1, y1 and z1, and then it moves to the point Q with coordinates x2, y2, z2. Now here I need to find the displacement of the particle from P to Q. So to find the displacement PQ vector, first of all I need to find the position vector of point P and point Q. So I will put the arrowhead at point P as well as at point Q in order to find its position vector. Suppose this is given by r1 vector and this is given by r2 vector. So as we have earlier studied about how to find the position vector, so I can write here OP vector equals to r1 vector, and this is equal to what? It is x1 I cap plus y1 j cap plus z1 k cap. This is position vector of point P with respect to point O. And I can find out the position vector of point Q with respect to point O, and this is what? OQ vector equals to r2 vector, and this is given by x2 I cap plus y2 j cap plus z2 k cap. Now I need to find the displacement of the particle from point to Q. Therefore I will join point P and Q, and I will put an arrowhead over the point Q. So this will be our displacement vector. Suppose this is represented by delta r vector. So you can see r1 vector and delta r vector both are represented in same order along the two sides of a triangle, whereas r2 vector is represented by the third side of the triangle taken in opposite order. So I can apply the triangle's law of vectors addition. Therefore I can write here OP vector plus PQ vector equals to OQ vector, or I can write here PQ vector equals to OQ vector minus OP vector. That is, I can say that the displacement vector PQ equals to position vector of point Q minus position vector of point P with respect to point O. If I need to find the QP vector, then it is equal to OP vector minus OQ vector. That is, we always write a displacement vector equals to position vector of point second minus position vector of point first. So now I can write here delta r vector equals to r2 vector minus r1 vector. Now substituting the value of r2 vector and r1 vector from here, I can write x2 I cap plus y2 j cap plus z2 k cap minus in second bracket x1 I cap plus y1 j cap plus z1 k cap. Now taking I cap from these two terms common, I can write here x2 minus x1 I cap plus, now here we can take, in these two terms I can take z cap common, so I can write here y2 minus y1 j cap plus z2 minus z1 k cap. This is what? Delta r vector. This is called as displacement vector of the particle from point P to Q. I can suppose this is x component of delta r, this is y component of delta r, and this is z component of delta r. Therefore I can write here delta r vector equals to delta r x I cap plus delta r y j cap plus delta r z k cap. Now these three are components of delta r. This is component along x-axis, this is component along y-axis, and this is component along z-axis. Now in order to find the magnitude of delta r vector, I can write here delta r mod of delta r equals to square root of delta r x square plus delta r y square plus delta r z square. Or I can write here delta mod of delta r is equal to square root of, what is delta rx? It is x2 minus x1, so I can write here x2 minus x1 the whole square. What is delta ry? It is y2 minus y1 the whole square, so I can write here y2 minus y1 the whole square plus what is delta rz? What is delta rz? It is z2 minus z1, so I can write here z2 minus z1 the whole square. This is what magnitude of the resultant vector, that is displacement vector. Now I can also find out the direction cosines of the resultant, that is displacement vector. If displacement vector makes an angle of alpha from x-axis, beta from y-axis, and gamma from z-axis. So direction cosines of the resultant vector, that is displacement vector delta r, is what? I can write here cos of alpha. Cos of alpha equals to what? It is x component of delta r, that is delta rx upon delta r. Or it can also be written as x2 minus x1 divided by square root of x2 minus x1 the whole square plus y2 minus y1 the whole square plus z2 minus z1 the whole square. Similarly, I can write cos of beta equals to delta ry upon delta r, and this is equal to what? y2 minus y1 divided by square root of x2 minus x1 the whole square plus y2 minus y1 the whole square plus z2 minus z1 the whole square. And similarly I can write cos of gamma, and this is equal to what? Delta rz upon delta r, and this can be written as z2 minus z1 divided by what is delta r? It is square root of x2 minus x1 the whole square plus y2 minus y1 the whole square plus z2 minus z1 the whole square. So these are the direction cosines of delta r from x-axis, y-axis, and z-axis. If it would be two-dimensional, if I would take only two-dimensional rectangular coordinate axis, then that time I would be written as delta r vector equals to x2 minus x1 I cap plus y2 minus y1 j cap, and that time magnitude of r vector would be equal to x2 minus x1 the whole square plus y2 minus y1 the whole square. And if I supposed that delta r vector is making an angle of theta from x-axis, then I can also find out the direction of displacement vector. Tan theta is equal to y2 minus y1 divided by x2 minus x1. This is in case if I find displacement vector in two-dimensional rectangular coordinate system. For that I need to find the direction of resultant vector or displacement vector only from x-axis or y-axis, and here I will get the magnitude, and here I will get displacement vector in vector form, and this is for three-dimensional axis. Now let's solve the sums. So let's take an example. Suppose there is a question: a particle is initially at point A having coordinates 2, 4, 6 meter, moves finally to point B having coordinates 3, 2, minus 3 meter. Write the position vectors of point A and B, of points A and B. Also find the displacement vector of the particle. So we have given the 2 points A and B in terms of their coordinates, And first of all, I will express these two coordinates in terms of their position vector with respect to the origin of a coordinate. So what will be position vector of point A? It will be OA vector, and this is given by what? This is x component, this is y component, and this is z component. So I can write here 2i cap plus 4j cap plus 6k cap. This is position vector of point A. Here we have given only coordinates. So to solve this problem, first of all, we need to find out the position vectors in terms of I cap, j cap and k cap. Similarly, I can write the position vector of point B as OB vector equals to, it is 3i cap plus 2j cap minus 3k cap. Now I need to find displacement vector of the particle. So displacement vector will be what? It is AB vector. As I told, AB vector is equal to what? It is equal to the position vector of the second point minus position vector of the first point. So which is the second point? Point B is second point and point A is first point. So I can write here OB vector minus OA vector. Now substituting the values of OB vector and OA vector, I get what? OB vector is 3i cap plus 2j cap minus 3k cap, minus what is OA vector? It is 2i cap plus 4j cap plus 6k cap. Now opening the bracket, I can write here 3i cap plus 2j cap minus 3k cap, and if I open the bracket, then the sign of all the terms will get changed, all terms will get negative. So I can write here 2i cap minus 4j cap minus 6k cap. Now taking similar terms together with, I can write here 3i cap minus 2i cap. These are two similar terms, plus 2j cap minus 4j cap. These are another two similar terms, minus 3k cap minus 6k cap. These are another similar terms. So I can write what? I can write here 3i minus 2i will be only I cap, 2j minus 4j will be minus 2j cap, and here minus 3k cap and minus 6j cap will be equal to what? Minus 9k cap. This is what? Position vector. Okay, I can also find out the magnitude of the displacement vector, that is mod of AB vector, and this is equal to what? Square root of the sum of the squares of the coefficients of I cap, j cap and k cap. I can write here square of 1 plus square of minus 2 plus square of minus 9, and I get what? Here I get 1 plus 4 plus 9 nines are 81. So if I add these two terms, I get what? Equals to square root of 86. This is what? Mod of AB vector. Now after taking the square root, I will get the final answer. This will be in meter. Now let's see what is the question number 2. A bird flies due east through a distance of 100 meter, then heading to the north by a distance of 50 meter. It flies vertically upwards through a distance of 20 meter. Find the position vector of the bird with respect to initial point. So suppose the east direction is represented by positive x-axis. Suppose the bird flies through a distance of 100 meter towards east, and then it flies in the direction of north. So north direction is over here, and it travels a distance of 50 meter, and then after it flies vertically upwards through a distance of what? 20 meter. So I have to find out the position vector, the final position. This is final position from the starting position. I have to find this displacement vector. So the vertical direction can be taken as z-axis, this direction can be taken as y-axis, and this direction can be taken as x-axis. So all the displacements are given here. I can take S vector equals to what? It is moving towards what? It is moving towards x-axis. So I can take it, what is the distance? It is 100 meters, so I can take it 100 I cap. This is where, this is the displacement of the bird, or distance traveled by the bird along east. And S2 vector is what? It is given along north direction, that I can take y-axis, and this is equal to what? This is equal to 50 j cap. And vertically upward is what? I have given the vertically upward direction as S3, and this I can take along the z-axis, that is 20 j cap, 20 k cap. So S1 is what? S1 is 100 I cap, S2 is 50 j cap, and S3 is what? 20 k cap. So what is its resultant displacement? I can write here, suppose resultant displacement is what? S vector. So S vector is equal to what? It is S1 vector plus S2 vector plus S3 vector. Therefore I can write here S vector equals to 100 I cap plus 50 j cap plus 20 k cap. This is what? Final displacement of the bird from the initial point. Now I need to find the magnitude of the displacement. So I can write here mod of S vector equals to square root of 100 the whole square plus 50 the whole square plus 20 the whole square. And on squaring I get what? 10,000 plus 2,500 plus here I get 400. On addition I get what? It is equal to 12,900. Therefore I can write here mod of S vector equals to, this can also be written as root of 129 into 100, that is equal to 10 root 129, which is almost equal to 11.36. So on multiplication with 10, it is equal to what? 113.6 meter from initial point. This is what? Displacement of the bird. All right, this is question number second. So question number third is what? An insect crawls from A to B, where B is center of rectangular slant face. So what we have to find? Initial and final position of the insect, and B, what we have to find? Displacement vector of the insect. Here we have diagram where this face is slant face. Initially the insect is at point A, which is in YZ plane, so it will have only Y and Z coordinate. Now it moves on the slant face and moves to the point B, which is center of this slant face. So at this time the point B will be in the space, that is it will have all three coordinates, X, Y and Z coordinate. So if I would like to write the coordinates of A, then it will be what? It will be 0 because it is in YZ plane, so X coordinate will be 0. So I can write here 0, 2, 1. And what will be position coordinate of point B? As it is a middle point, so its coordinate will be half of the coordinate along X axis, Y axis and Z axis. So its X coordinate is 3, so it will be 3 by 2. Its Y coordinate is 2, so it will be 2 by 2, that is 1. And its Z coordinate is what? It is 1, so it is 1 by 2. So now I can write the position vector of initial point. Initial point is what? A. So position vector is what? OA vector, and it can be written as, because X component or X coordinate is 0, so I can write 2 j cap. I can write 2 j cap plus k cap. And what is position vector of point B, which is final point? It is OB vector. OB vector is equal to what? 3 by 2 I cap plus j cap plus half k cap. Now I've got the position vector of point A and point B, which are initial and final positions. Now I need to calculate displacement vector. So displacement vector is what? It is moving from A to B, then it will be AB vector. And AB vector is what? It is equal to position vector of second point, that is final point, minus position vector of initial point, that is OB vector minus OA vector. So I can write here what is OB vector. It is 3 by 2 I cap plus j cap plus half k cap, and minus what is OA vector. It is 2j cap plus k cap. So if I open the bracket, it will become what? 3 by 2 I cap plus j cap plus half k cap, and here if I open the bracket, then sign of all the terms inside the bracket will get changed, and if it is plus, then it will become minus, and this will also become minus k cap. So I can write here 3 by 2 I cap. There is no other I component, or there is no other x component. So now here I have j cap minus 2j cap, so it will become what? It will become minus j cap, and here I have half k cap, and here minus k cap, so it will be minus half k cap. This is what? AB vector. This is the answer of this question. And if I need to calculate the magnitude of this displacement vector, then I can take square root of 3 by 2 the whole square plus minus 1 the whole square plus minus half the whole square, and after calculating we'll get the magnitude of displacement vector. So question number 4 is what? If coordinates of point A is 4 comma minus 2 comma 3 and AB vector is equal to 3 I cap plus 4 j cap plus k cap, what is coordinate of point B? So here we have to find the coordinate of point P similar to point A. Here I have given the coordinate of point A, so its position vector is what? OA vector is equal to 4 I cap minus 2 j cap plus 3 k cap, and already we have given AB vector is equal to 3 I cap plus 4 j cap plus k cap. So what we need to find? We need to find OB vector is equal to what, and hence we have to find what is the position coordinate of point B. So as we know that displacement vector AB is equal to position vector of B minus position vector of point A. So what is OB vector? OB vector is equal to AB vector plus OA vector. Now substituting the values of AB vector and OA vector, I can write here 3 I cap plus 4 j cap plus k cap plus what is OA vector? It is 4 I cap minus 2 j cap plus 3 k cap. Taking similar terms simultaneously or together, we can write 3 I cap plus 4 I cap, and in second bracket I can take 4 j cap minus 2 j cap plus in third bracket I can take k cap plus 3 k cap. 3 I cap plus 4 k cap, 4 I cap is equal to 7 I cap plus 4 j cap minus 2 j cap is equal to 2 j cap, so it will be 2 j cap, and k cap plus 3 k cap is what? It is 4 k cap. This is what? OB vector. So what is position coordinate of point B? Coordinates of point B are 7 comma, what is coefficient of j? It is 2, and what is coefficient of k cap? It is 4. These are the position coordinates of point B. Alright, so position coordinates can be written as in terms of position vectors, and position vectors can also be written as in terms of position coordinates. So friends, that's all for today. We'll meet in the next lecture with the new topic, addition of the two vectors in terms of their rectangular coordinates. Thanks for watching.